Hi, hello, very good morning to you all. I'm Dr. Harika Kishore. On behalf of Vista's Learning, I'm here as your biology educator. V-Learning, it's an online education platform which works with an ideology of providing quality education for all. Visit our website www.v-learning.in where you are going to get an access for all the live classes, recorded sessions, study materials, and also concept videos. Moreover, you are going to get this lecture notes in the form of PDFs. And also get your acquaintance with all the channels that are made available, and also subscribe to the channel Vista's Learning Class 11 and 12. If you find this session useful and informative, click on the like and share this session with your friends. And click on the bell icon such that you are going to get all the upcoming video notifications. Now, in continuation with the last session where we have been discussing about the chapter Organisms and Populations, which comes under the unit Ecology. So, in the previous session, we discussed about various things that comes under population attributes, which includes birth rates, death rates, gender ratio, age distribution, in which we also studied about age pyramids, and finally we also covered population density, which is otherwise called as population size. That is represented by a numerical, that means that is represented by letter capital N. Now, so here in this session, let's move ahead with another topic which comes under populations, that means population growth, under which we are going to discuss about growth models also. So if two different conditions are provided, organisms starts growing, showing two growth models. Basically, they are of, one is exponential growth rate and the other one is logistic growth rate. So here, let's understand about what is this exponential growth rate. If you find the population density at any given period of time, it will never remain constant. We already know that population density, also otherwise called as population size, it is represented by capital N. Look at here, the size of the population, nothing but population density at any species, for any species at any given time of time, at any given period of time, for any species is not constant, not a static parameter. That means it will never remain the same. It will be changing, and that changes are influenced by so many factors like food availability, weather, that means climatic conditions, and habitat, like favorable conditions or unfavorable conditions which that are facing in a particular habitat. All these are acting as a factors which will never let to remain as a static condition, that means constant condition. The thing is, population size or the population density keeps on changing. It never remains constant. It is not a static parameter. And the factors which is going to influence, which is going to change this population size, they are, it keeps changing with time. It is not static. Which is not static? Population size or the population density is not static. It keeps on changing with time. It depends upon the factors. Just now we mentioned what are the factors, which includes availability of the food. Definitely, if the food availability is there, then there is an increase in the population size. If there is a lack in food, then it is going to decrease. That means it is showing its decreased effect in the population density. So this is a factor, which is a factor. Food availability is one of the major factor which shows its influence on changes that are coming in the population density. Along with the food availability, there are some other factors which includes predation threat or predation pressure. And also adverse weather, unfavorable weather, extremes of the climatic condition, extreme weather conditions. So these are all the factors we can take into consideration that they are capable of changing size of the population. They can change the population density. Now, here, in fact, it is these changes which are caused by the different factors, which includes food availability, adverse weather conditions, predator pressure. All these factors are going to show some changes in the population size. And it is these changes in population density that gives rise to some idea of what is happening to the population, whether the population is growing or whether the population is decreasing, whether it is increases or whether it is decreases, increasing or decreasing. Like flourishing, which includes increasing the population size, or declining, diminishing or decreasing the population size. All the factors, all the factors which includes like food availability, predator trust, that means predator pressure, or the weather changes, all these are going to show an influence. Are they going to show, results in some changes, and that changes can be seen in the population size or population density. And that changes is in terms of increase in the population density or decrease in the population density. Now, whatever might be the reasons, like whatever the factors, whichever the reason might be, the density of the population, that means population density in a given habitat during a given period, fluctuates to the changes basically because of 4 processes. And what are that 4 processes? That 4 processes are first one, natality. Second, mortality. Third, immigration. Fourth, emigration. The change in the population density or change in the population size is influenced by the 4 basic processes, and that 4 basic processes are natality, mortality, immigration and emigration. So here, 2 out of which, out of this 4, 2, what are they? One is natality, and other one is immigration. 2 of which, natality and immigration, contributes for the increase in population density. Here, these 2 factors, that means 2 basic processes, natality and immigration, contributes for the increase in population density, right? Which is represented by population density or population size, that is represented by N, capital N. And the other 2 factors that are other 2, one is mortality and emigration. These 2 contributes for the decrease in population size or density. So here Out of 4 factors, natality, mortality, immigration, emigration. These are the 4 basic processes which contributes to the change in the population size. Out of which 2, natality and immigration contributes to increase the population size, whereas the other 2 factors, other 2 basic processes, what are they? Mortality and emigration contributes to decrease the population size. Now, let's understand these 4 basic processes. So here, first one, natality, which refers to number of births. Natality is nothing but number of the births that is taken while the time is being considered. So here, during a given period in a population that are added to the initial density. Initial density means initial population density. Natality is the number of the births during a given period of time that is happening in the population that are going to show its change in terms of addition. So as it is adding, we give plus sign for the natality. Coming to mortality. This is the number of deaths. Number of deaths. This is number of births and mortality is number of deaths. The same thing. In a given period of time that is happening in the population, as it is contributing for decreasing, we take it as minus sign. So this is all about natality and mortality. Now, let's understand about immigration and emigration. Immigration is the number of individuals of a same species that have come into the habitat. Into the habitat. This is very, very important. Into the habitat from elsewhere. So, during the, and this is also taken into a time period. Time period has to be taken into consideration. During the time period under consideration. Now, so here, this is a number of individuals of the same species that are coming into the habitat. So, immigration is into the habitat. Remember like this, immigration is into the habitat. Now, emigration. Emigration is the number of the individuals of the population who left. This is into the habitat. This is who left the habitat. So, E, exit. These individuals left the habitat. Left the habitat and gone elsewhere. Here, from elsewhere, and here, it gone to elsewhere. During the time period taken into considerations. So, here, immigration is all about a group of the individual, like number of the individuals coming into the habitat during a particular period of time that is taken into consideration. Now, the same thing, emigration is the number of the individuals that are leaving the habitat, left the habitat. It is into the habitat, it is left the habitat. That is the thing we have to remember. Now, we understand the 4 basic processes: natality, birth; mortality, death; immigration, number of the individuals coming into the habitat; emigration, number of the individuals leaving the habitat, right? Now, so by this is the flowchart that has been given in your NCERT textbook. So here, population density how it is going to be influenced by the 4 different basic processes, out of which the first one is birth, represented by capital B. As it is adding, increasing the population size, we are representing with plus. And also emigration, number of the individuals coming into the habitat, again it is adding. So it is contributing for population density increase. So again plus. Now opposite to this, emigration. Group of individuals which are moving away from the habitat, left the habitat, it is leaving the habitat and moving to somewhere else. So it is contributing for the decrease to this population density. So minus. Same way, mortality, which is represented by capital D. This is represented by I, and it is represented by E. As mortality also resulting in decrease in the population size or decrease in the population density, we are giving minus signs. So now the two factors, as we already consider, which are useful, which are contributing to increase the population size, one is birth plus immigration, right? And the two basic factors which are contributing to decrease the population density, one is death plus emigration. So to get the population density at the time t plus 1, that is the new period of time. Initial time is represented by t, and after that the new time is represented by t plus 1. So in order to represent the population density at the time t plus 1, equation goes like this. Population density, capital N, t plus 1. We need to know the population density at the time t plus 1. So the initial population density, initial time is represented by t, right? Capital N, t, where both the birth, that is natality, and immigration counts to increase, therefore we are adding this two, and this both are useful to decrease, are contributing for decrease in the population size, so we are adding this both. But we have to minus, as these are contributing to the decrease in the population size. So therefore the equation goes like this. This is what it is given in your NCERT textbook, where B is natality and I is immigration, capital D is mortality, and capital E is emigration. That is what the equation represents. So this is the equation what we got from this flow chart, right? Clear? Okay, let's move on. So here, this is an equation which is very important. Now, you know each and every term, why we are adding up these two processes and why we are subtracting here, because these are the basic processes which contribute for increasing and these two contribute for decreasing. So we have to subtract these two basic processes, and this two basic processes has to be added up because it contributes to increase the population density. And this is how the population density at the newer time period can be get by multiplying, that means by taking the consideration of t as an initial time. So here, if n is a population density, right? If n is a population density at time t, this is the population density at time t, initial time. Then its density at time t. This is a new time period for which we need to express the population density. So the population density at the time t plus 1 would be its initial population density. That initial time is represented by small t. And here we have added two factors, two processes. What are they? Natality and immigration, and subtracted the both processes which contributes to decrease the population density. They are mortality and immigration. So here this is immigration and this is emigration. Now that population density will increase if the number of births is represented by capital B plus number of immigrations which is represented by capital I. Capital B plus capital I. If this factor increases, then there is an increase in the population density and is more than the number of the deaths. Number of the deaths is represented by capital D and the number of the emigrants which is represented by capital E. So capital D plus capital E. If this value is more than this value, then it is going to contribute for the increased population size, increased population density. That's it. Right? This equation is very, very important. You have to remember. Now, moving on. So here, we know that population density shows its changes, and that changes are influenced by the four processes, basic four processes. What are they? Birth, that means natality; death, that means mortality; immigration, emigration. Though all these four basic processes influences the changes that are happening in the population density, but majorly mortality and natality rate are going to show its great influence. Look at here. Under normal condition, births and deaths are the most important factor which is showing its influence, that is going to influencing population density. What are the other factors? The other two factors get its importance. Two factors assuming importance gets its importance only under special conditions. Only under special conditions. If you consider the normal conditions, to see how the population size or the population density is going to change, then you have to take only two processes under consideration, that are births and deaths, natality and mortality. Under very special conditions only, you're going to take another two factors. What are the two factors? Immigration, emigration. Now, take an example of that special condition. Like, for instance, if a new habitat which is not occupied previously, a new habitat is just being colonized by a new species, then immigration, as it is newly formed habitat, as it is colonized, that means forming of the colonies has been raising. Therefore, the number of the individuals which are coming into the habitat, immigration is nothing but the number of the individuals that are coming into the habitat, then it is going to take an important role. So, immigration may contribute more significantly to the population growth or population size or population density than birth rates. In that condition, immigration has its special importance, special influence to show its contribution towards the rise of the population growth. Until then, if it is not special condition, it is normal condition, then you have to take consideration of births and deaths. Right? Now, let's move on. So here, we have been concerned about raising, ever raising, ever raising. Unbridled means unstoppable, uncontrolled raise and increase of human population. Human population growth and the problems which comes associated with the increased human population and problems that are created by it in our country. And it is therefore natural for us to get curious about, to know whether the same raising rate is happening with the other animal species also. Curious if different animal population in nature behave the same way. Behave the same way means whether it is also ever increasing its population growth, population size, or show some restraints means control. Here is an uncontrolled growth, right? So we are searching for the solution where we can get a control over this uncontrolled solution. Control on growth. We are trying to get a control on growth because the human population growth is ever increasing. Now, perhaps we can get some ideas, we can learn some lessons or two from nature how to control population growth. Simple. This line suggests that, to summarize this thing, as there is an uncontrolled increase in the human population growth, we are in such to get some idea, to learn some lessons from the nature, whether we are searching whether the same pattern has been followed by some other animal species. If yes, then how can we get a control over this uncontrolled uncontrolled growth, right? Now, here, as we already said that, the growth models, right? Under two different conditions, we can get two different types of growth models. One is exponential growth model and other one is logistics. Let's discuss first about this exponential growth model. This is imaginary situation where the conditions are unlimited availability of resources which never exists. Here, assume a situation. It's an example. We have to imagine that the availability of resources are unlimited, right? Resources, nothing but food crops, availability of the land, favorable habitat. Resources in the form of food and space availability. If there is an unlimited resource availability, that is going to obviously essential for unimpeded means uncontrolled increase in the population growth. So uncontrolled growth of the population takes place because how the population can be controlled? If there is a lack, if there is a decreased availability of the food, if they are predators, then we can see certain decrease. If there are more deaths, if there are more immigrants, then there is a decrease in the population. Here the situations are completely opposite. Availability of the food is unlimited and the space is available, unlimited space is available. Then obviously it is resulting in an ever increasing unstopped growth of the population. Means there is no factor that is going to stop the growth of the population. Here the growth of the population is unstoppable. Now here, ideally, when resources in the habitats are unlimited. Imagine in a habitat the resources are unlimited. Availability of the food is there, availability of the space is there, habitat is providing you much favorable condition, then obviously there is a rise in the population growth. Each species has the ability to realize fully its innate potential to grow in number. Each and every species at its maximum, at its best, it is going to grow in number. Each and every species is growing in number, which resulting in the growth in population density, population size. As Darwin observed while developing his theory, of natural selection. This is what happened. This is a condition completely unrealistic. We have to imagine there is an habitat which is providing you limitless, unlimited resources. Then it is going to show an exponential growth. Okay, now here then if the resources are unlimited, resources availability is unlimited, then the population grows in an exponential fashion, which is otherwise called as geometric fashion. Exponential fashion, where initially it may take some time to adjust, lag. Once it got adjusted to the resources availability, as the resource availability is limitless, that is unlimited, the growth of the population keeps on growing, and this is an exponential fashion, otherwise called as geometric fashion. Here time, and here population density. Population density keeps on raising and gives result in a shape called as J-shaped curve. This is exponential fashion, or otherwise called as geometric fashion. Here we are imagining a condition where the habitat is providing endless, that is unlimited resources. Then okay, now so here if the population size if in a population size the birth rates, see, as we already know while we are discussing about the natality, birth, capital B represents births, right? Same way, capital D represents deaths, right? Small b represents birth rates. Small b represents death rates, right? So here birth rates are represented by small b. Birth rates are represented by small b. Now we are taking into consideration of not total number, as we are calculating the birth rates, where birth rate is equal to number of the births or number of the deaths divided by total number of the population. That means per capital N, right? So birth rate is equal to births, number of births, B. Per capita, we are not considering total number, but we are considering per capita births. That means divided by population density. That means total number of the population. Now, and it is represented by small b, right? The same way, death rates are represented by D. Same way here also, again, we are not taking total number, but per capita death rates. Same way, per capita birth rates are considered here. Here also, per capita death rates are considered. Per capita, that means here also, D, death rates is equal to death per capita, right? So here, see, B. Capital B is equal to small b, capital N. Same way, capital D is equal to small d, capital N. If you want to find the change in the population density by change in time, that means difference, we need to get the difference. So, is equal to birth minus death. Why we are not considering the other factors? See, the change in the population density per time is influenced by the 4 basic processes: natality, mortality, immigration, emigration. But under normal conditions, we are considering only 2 conditions. What are they? 2 factors. What are they? Births and deaths. Births divided by death, that is going to give your population density per period. Always time period is taken into consideration. So this is the actual 2 factors which we are taken here. See, small d. Already I have represented here, right? Then increase or decrease, that is a difference. Difference in population density by difference in time, that is change. Difference initially, whether it is increasing or decreasing, that is change in population density by changing time is equal to births minus deaths. But now you know what is capital V and what is capital D, right? Just substitute here what you get. Change in population density by change in time is equal to capital B minus capital D, birth minus death. That is equal to, these have to taken per capita, right? So capital B, what is the value for the capital B? Small b n minus, what is the value of capital D? Small d n. Let me write here. Right? N. We can make it common. Right? So now, here is the thing that is given. This equation is directly given in your NCERT. Before that, how we got? We know by this. Explanation, right? This is what? Small b minus small d into n. Small b minus small d into n. I'll write here. So, right? Birth rate into population density. Same way, this is first equation, this is second equation, right? We are here to calculate the change in population density by change in time. Change in population density by change in time. What is that? Birth minus death. Now, by equation 1, substitute the values. Simple substitution. B is equal to small b n minus D is equal to small d n. Right? This is what it is given in your NCERT textbook. Now, here, this small b minus small d is taken as R. Let's consider that small b minus small d is equal to R. Then what happened? We have to replace this with R. That's it. Change in population density divided by change in time is equal to R into N. This is very, very important. So by now we got 2 equations, which is very, very important, right? Moving on. So what is that R? We have taken small b minus small d. It is considered as R, no? That R is a very, very important factor. This R, the R in the equation is called as, this is very, very important. 2 equations and you have to remember what is this R. That is intrinsic rate of natural increase. Intrinsic rate of natural increase, and is a very important parameter. You have to remember this R. What is R? Intrinsic rate of natural increase. It's a very, very important parameter chosen for assessing impacts of any, assessing means to evaluate whether it is increasing or decreasing. Which has chosen this parameter R as a parameter which represents the intrinsic rate of natural increase. Intrinsic rate of natural increase. It's a parameter which has been chosen to assess the impacts of biotic, living, abiotic. Abiotic factors means non-living factors like temperature, light, pressure, sunlight, water, soil, like that, on population growth. And now, another important point. We know now what is that R, right? In your NCERT textbook, the value for this R has been given as your examples, and these are very, very important to remember. Now, we have to remember two important equations followed by what is R, and also here also an important questions which has been repeatedly asked in the previous year questions. Now here, to give you some idea, by this we are going to get some idea about magnitude of R values, and that value, the value of the R for Norway rat. The value of the R for the Norway rat is 0.015. You have to remember this. This is important. This is important. And also for the floor beetle, the R value is 0.12. This is important to remember. And in 1981, year is already given. So in that year, what is that? 1981, the R value for the human population in India was 0.0205. Remembering this numericals, the R value of Norway rat, floor beetle, and the human population during 1981 is important. So this is also important to remember. Now, here, so the equation what we got is this, right? This is the final equation which is very important. If you take time versus population density, the exponential growth will give you this curve, and as it is very close to numerical J-shaped curve. This is also important. Exponential growth model gives J-shaped curve, which is very, very important. Look at here. Here, this is the graph which represents both growth models. One is exponential growth curve, and other one is logistic. So here, let's take this one, which is a when responses are not limiting the growth, unlimited availability of the resources, then the plot is exponential. The other we'll see. So here at present we are considering about the first growth model, and that is called as exponential growth. So this is the red image what is given. You can see now. See, this is the growth which represents exponential growth, and as it is taking a shape of J-shaped curve, right? So the above equation describes the exponential or geometric growth pattern of the population and results in a J-shaped curve when we plot n versus time. N in relation to time, right? Now, we'll discuss about this graph later classes. Now, so here, this is the final equation. To get an integrated form, Here, if you have familiar with the basic calculus, you can derive the integral form of this exponential growth equation. Integrate is where this equation is just given. There is no need to remember, just know this is an integral form of the exponential curve. Exponential growth curve equation is this. That means exponential growth equation is this, and this is the integrated form. Integral form of the exponential growth equation, where capital N at time t, initial population density, e to the power of RT. What is this E? So here, just remember what is E. There is no derivation that is given to you, and it is all important to remember this form. What is this? This is an exponential growth equation. Just remember the exponential growth equation, and there is no need to remember this integral form of the exponential growth equation. But you just have an idea what is it. And here we already know this is at the time t, this is at the initial times. So population density after time t, population density at the time 0, that means initial population density, and R we already know, ERT, right? T at time t, R we already know, it's an intrinsic rate of natural increase. And now E is the base of natural algorithm. No need to remember this numerical also. Important the equations or the equations what we have discussed in the beginning. Now, so here if any organism is following this exponential form, actually the conditions which are given to this exponential growth model is completely imaginary, because there is no habitat that is going to provide limitless, endless resources, no predators, and all the favorable conditions are given to the habitat. Never happens like this. This is completely an imaginary model, right? So exponential growth, where any species growing exponentially under unlimited resources conditions can reach enormous population density. Definitely the population density keeps on increasing because it is provided with the unlimited resources, right? And this will achieve within a short period of span, no matter how big the organism is. Darwin showed how even a very slow growing animal like elephant could also reach enormous number in the absence of checks. In the absence of checks means no predators, no less availability of the food. Always the availability of food is endless, that is unlimited food availability. Food in the sense of resources, whatever habitat it is providing, food is available, space is available, favorable conditions are available. If all the conditions are available, no matter how the growing, that means fast growing animal or slow growing animal, no matter how the growth happens at what time, even the slow growing animal can also reach an tremendous increase in the population size. That is what this indicates, right? Okay. In this class, we have finished the exponential growth model. Let's discuss about the logistic, which is a realistic growth model, in the coming up class. Until then, keep learning with We Learning.